We're going to go solving quadratics by graphing, and we've kind of already answered the first one. The first question here asks how high a ball is, okay? Now, y, or in this case h at t, our y-axis, is measuring height, and t is measuring time. When a ball is thrown or dropped is when t is equal to 0, and t in this case is our x-axis. So when x is 0, we're looking at a y-intercept. So instead of plugging 0 in, when in standard form we know the last term is technically the y-intercept. So our answer to number 1 is 40 feet. This ball was dropped at 40 feet or meters, whatever the unit of measurement is. Okay, so we breeze by that part. Height, or in this case, the max height. The max height of any parabola will be the vertex, okay? Now we know in standard form we can't pick out the vertex easily, but we can factor. We've learned to factor and then find a vertex to that. So let's factor this equation. H at t is equal to negative 5t squared plus 10t plus 40. Okay? The very first step to factoring is always look for a common factor. And in fact, because our first term is negative, I'm going to factor out a negative. It'll be easier for me to work with factoring if my first term is positive. So we're going to factor out negative 5 from each of these terms. That will leave us with, and remember, this negative 5 does not disappear. We're left with t squared minus 2t minus 8. Okay. From here, we have a trinomial that we can factor. If you want to factor by decomposition, you can. Remember, we usually do first term and the last term. Now, what's the very first term in this question? What's the coefficient in front of t squared? 1. So when a is 1, there's a shortcut we can use. What's the shortcut? Nobody remember? Okay, we won't use the shortcut. We'll talk about it after. Since we don't know, we'll go with what always works. We'll find the factors of the first term. So factors of 1 are 1 and 1. Factors of 8 are 1 and 8 and 2 and 4. We know that their products need to add up to our middle term, which is negative 2. Obviously, 1 and 8 and 1 and 1 won't work, so 1 and 4 and 1 and 2. In order to add up to negative 2, which of these values have to be negative? 4. Okay? Which means the number we multiplied by needed to be negative. Let's check our product. What is negative 4 times positive 2? Perfect. So we know that works. We've checked that out. So now we can take our terms. Remember that negative 5 is still involved, so we have negative 5, and we go to put this into brackets. Because they're both 1, the first term will both be x and x. And because they're the same, it actually won't matter which bracket we put it in. But normally, let's say this was the first one, the negative 4 would go in the opposite bracket, and the positive 2 the other bracket. The shortcut, if you had forgotten, because it was a, we just needed two numbers that multiplied to negative 8 and added to negative 2. Negative 4 and 2 fulfill that idea. Okay. Now, in order to find a vertex, we need to find some intercepts. And our x-intercepts, so when we cross this x-axis, is when y is equal to 0. So we're going to set h at t at a height of 0. Okay? So our y-axis is 0. Now this negative 5, I want to get rid of it, so let's divide both sides by negative 5. Does it change the 0? Still stays 0. But what does it do over here? That's right, it cancels out that negative 5. So we have 0 is equal to x plus 2, x minus 4. From here we know that in order to multiply to get a 0, one of these factors must be 0. So we're going to test for both of them. 0 is equal to x plus 2, and 0 is equal to x minus 4, which gives us x values of negative 2 and positive 4. Now, are we working with x, or are we working with a different variable? What was that other variable? What represented x in this equation? Do you guys remember? T, that's right. And t stood for what? Time. So what is this telling us in terms of time? When is the height 0 for throwing something usually?
0.
What would 0 mean? What has the ball done? Not that it's done nothing. We've thrown it up in the air, and it comes in, hits 0 at when it... We're not sure? Okay, we'll come back to that. That's okay. From these x-intercepts, we can find the vertex. What do I do from here? That's right. We take the axis of symmetry. So we add the two values together, r plus s divided by 2. In this case, it's negative 2 plus 4 divided by 2. This will give us the x value of the vertex, right? When we're looking for our vertex, the axis of symmetry is the x value. Negative 2 and 4 is 2 divided by 2 is 1. So the axis of symmetry is at 1. So at 1 second is when this thing's going to hit its max height. We need to figure out what its max height is. How do we figure out the max height once we have this value of 1? Yeah, we plug it in. Okay. Now we can plug it into the original, which we did yesterday, the standard form. I'm going to plug it into the factored form and show you that it gives you the exact same answer. Okay. So we had h at, and in this case we'll go h at 1 is equal to, our factored form was negative 5 x plus 2 x minus 4. This was our factored form. So we're going to plug 1 in for both of the x's. Negative 5, 1 plus 2, 1 minus 4. Negative 5 times 3 times negative 3. What's a negative times a negative? And a positive times a positive? So we know we're going to have a positive answer. 3 times 3? 9. 9 times 5? 45. So what is the max height of this ball? It's okay. It's okay. It's okay. Oh, it's not okay anymore. All right, a little hiccup, but the height is 45. So, the max height, the second part of our question. What is the max height? The max height of the ball is 45. So let's again keep drawing our rough sketch. Remember, we started, or we were thrown from a height of 40. The max height was after 1 second, and it was 45. So it's gone up from where it started. Okay? I'm just drawing a rough sketch here. We'll get a much better graph after. So we know after 1 second, it reached its max height at 45 feet in the air. Now, the third question says, when does it hit the ground? And this is what I was referring to earlier. The ground is represented by what height normally? 0. So when we find the x-intercepts, and we were talking about time, when does it hit the ground? Negative 2 and 4. Okay, so what does that mean? Negative 2. What does negative 2 talk about? 2. Negative 2 of time. Can we be negative 2 seconds? Do we really measure before we've thrown a ball? No, in reality, that doesn't make sense. Okay? But what does the positive 4 mean? So at 4 seconds after we've hit the ground. That's going to keep doing it. So, at 4 seconds, we finally hit the ground. Okay. Now, because parabolas are symmetrical, it also said at negative 2. But in reference to the real world, that doesn't make sense for us, right? At 4 seconds is when this finally hits the ground in the real world for us. Now, this is the hard part. When is the ball the same height it was thrown from? What height was it originally thrown from? 40. 40. Okay. And we want to know when it's 40 again. Okay. And we can kind of use some deduction to figure this out. We want to know when the height is 40 in this case. Okay. So what we're going to do is we're going to take this original equation. Yes, that's exactly what we're going to do. Okay. When we take our equation, that's going to happen negative 5 t squared minus, is it minus or plus 10, guys? It's plus, right? Plus 10t plus 40. Instead of solving when the height is 0, that's when it hits the ground, we want to know when the height is 40. So we're going to plug 40 in for the height. 40 is equal to negative 5t squared. I have to go slow in order for that to not happen. Plus 40. In order for this to work, in our terms of our factoring, we actually have to do set it equal to 0. So I'm going to move that 40 to the right side of the equation. And when we move 40 over, it becomes what? Negative. What's going to happen to the end part of this? What's positive 40 and negative 40? 0. So on the left side, we'll have 0. We've moved 40 away. We have 0 is equal to negative 5t squared plus 10t. Now we're going to factor this to find out when our height is 40. So here we can take a common factor out. What common factor can we take out? That's right, negative 5t. We take negative 5t out, we're left with what? T minus 2. Good. It's still equal to 0. I want you to think of this as a factor and this as a factor. Okay. This is where we're going to split again. We're going to set negative 5t equal to 0, and we're going to set t minus 2 equal to 0. How do I isolate t here? 0 divided by negative 5, which is what? Is 0. And here t becomes, this is a negative here, so it becomes positive 2. So let's make sense of this. This is telling us it's at a height of 40 at 0 and 2. Does that make sense? Were we at a height of 40 at 0? Yeah, so we knew that already. That's where it was thrown from. But it takes it 2 seconds for it to get back to the original height of 40, for the ball to go up and then come back down. So after 2 seconds, it's on level from where the guy has thrown the ball.